Okay, so I've uploaded my sinus infection data, and now I'm going to run it, making sure that I change the name to sinus infection so I'm not confused. Okay. Now we're going to go over to binary logistic regression, and there's our data there. Our response variable is going to be, are you sick? And as you can see here, it's met its limit of field names, so be very careful with field names and things like that. Okay, so level of interest, we were looking for the ones. Classification variable, this time we're going to put gender in there. Continuous, I'm going to grab all of these here. And this time we're going to hit output. Again, create score data set. Scores, I'm going to change that to sinus infection. Okay. Okay, so now we're going to run that sinus infection data. I just did that import. So here's how I set it up. The response variable, are you sick with the sinus infection? 1 or 0. Gender is the classification. Remember, this time I gave you M and F. Instead of what was in the pneumonia data, I gave you it as 1s and 0s. Our continuous variables are these suspects down here. And what I want you to do next is go over to output, create a scored data set, change the name to sinus infection, similar to what we just did for the pneumonia, and hit run. So you're going to have your typical stuff here. I want you to note the male and female, how it was broken out. Also note, this time around we have different information. The previous file, which is the same patients as this file, you still have the same 5,000 patients. Okay, but this time around, not all of them have pneumonia. You have quite a few actually that have sinus infection, but you also have quite a few that do not have a sinus infection. So what I want you to do next is download the file, and I want you to merge the results of the sinus infection with the pneumonia data set just to compare the results. Okay, so do that, but also study the estimates. Okay, look for some smoking guns. For example, I'm looking sinus pressure here. If we're talking about a sinus infection, and wow, we've got a 3.2 here. We've got a pretty strong estimate there. Lymph nodes swollen is another one. Coughing up mucus is another one. Go through this and study it up. See what you can learn from the results. Keep in mind, these results are the same patients that were studied with the pneumonia. So it is possible that you have patients that have sinus infection and pneumonia. It's also possible that you have patients that have pneumonia but no sinus infection, and vice versa. So be careful of that. Play with this. Have some fun with this. Let's go back to the library here just quickly. Where is it? Okay, it's right here, sinus infection. I'm going to right click. We're going to export that to our home files. And now we have that file there. We've got the logistic scores right here. We will download that. Okay, and when I say merge the files, what I'm saying is create a new sheet for patients, sinus infection, pneumonia. Okay, and so these are my patients. Okay. Guess I didn't need to create a new column there. I've already got the patients column there. And just go over here, grab your scores. These are your scores for ones. Okay. Okay, and go grab your pneumonia and do the same thing. Remember that these are scores. Okay, so this is my pneumonia file. Now keep in mind your results may vary. And how you set this up, please do not sort your results before you paste over. You're not going to have a good time. Okay. So these are the results, and this is what you really need to study and look at. Okay. Now we do have some pretty high values here, but we also have some low ones, some 45s, according to the 80s. So you really need to think about this a little bit and just study the differences. Do one of those descriptive statistical analyses. Use a 50% threshold. Count the number of people that have a 50% or higher pneumonia, and then count the number of sinus infection. Maybe do a count ifs. If this equals greater than equal to 50% and this equals greater than equal to 50%, put a 1 kind of thing. Do a little study on this. Look for some smoking guns. For example, I've got a minimum score of 0.001 and I have a minimum score of basically 0 there. Are they the same thing? Well, let's just play around a little bit. Certainly sort this, but let's just look here. Well, look at that. We do have a lot of zeros. We do have a lot of really weak, well, not too many, 73 out of 5,000 are at this level. But we do have a couple people that we feel certain have pneumonia, but not a sinus infection. So there are some nuances to this. Some of the data is like, wow, it looks like a lot of people have pneumonia and sinus infection. Sure, but remember, we're really looking for those smoking guns here. We're looking for the really high numbers to evaluate our model. So that's what I want you to look at this week, is try to combine the studies. You could even, nothing's stopping you here. You can even take the same data and do something crazy like this. Linear regression, right? Oops. Regression. In fact, I challenge you to do this. Challenge you to, whoops, see, I just messed that up. This is what happens when you're having too much fun with data. This reminds us that we're all human. So now, linear regression. Go into SAS, just for fun, and run a linear regression comparison to see, because remember, we have the actual results too. If you go back to the original data sets, we have confirmed sinus infection, because this is really where the rubber meets the road. It's not in, oh, look at my acute R squared or my A1C or AIC. It's confirmed compared to the model. Confirmed pneumonia. Bring that in. See what you can do with that. Just have fun with this. Tear it up, as they say. Tear it up. Have some fun. See what you discover. Share it in your paper. I'd love to read it and see what you discover. Any smoking guns, any comparisons across here. Just be free with it. Enjoy it. Enjoy the work. And we'll talk to you soon.